Hello, everyone. This is James Shore with Let's Code Test-Driven JavaScript. I'm recording this on July 29th, 2014. You're watching The Lab, which is where we explore, experiment, and generally mess about. And today in The Lab, something I know a lot of you are excited about. We are going to start a new series focused on front-end frameworks. And specifically, today we're going to look at React, the hot new library from Facebook. This is described as a library for building user interfaces. They say it is the V in MVC. And today, what I'd like to do is put it through its paces, try it out, build something with it, and see how it really works out, see what we think of it. This ended up being a huge episode. There's so much content here. I had to split the episode into two parts. In this first part, we're going to look at fundamentals. What does it take to get React up and running in a professional style environment where you've got automated builds and you're not using the dev mode scripts and so forth. And then in the second part, we'll actually build out an application and look at architecture and design. In this part, we're going to start out by looking at the challenge. How are we going to put React through its paces? Then we'll get React up and running. We'll take a look at JSX in the browser in development mode. JSX is a special language that React uses. We'll make a mock-up of our challenge application, and then we'll look at using JSX in production like you would in a real-world project. Next, we'll look at modularity, and then we'll close with a look at how you can unit test React. And then next month, in part 2, we'll continue on by looking at how React deals with architecture and design, specifically in the context of our challenge application, which I've chosen to be a bit more challenging than your typical to-do app. So that is what's ahead. Thank you for joining me, and welcome to the lab. Now, those of you who have been watching Let's Code JavaScript for a while know that I am not a huge fan of frameworks. So I'm actually already pleased by React because they describe themselves as a library, not a framework. I have several issues with frameworks that I would like to explore today in the lab with regards to React. Now, my biggest concern with any framework is that it locks you in. I worry that a framework is going to make you work in its style and really limit you from making changes in the future. If you've been paying attention to the JavaScript front-end world, you know that these frameworks are coming and going. Fads are coming and going. It seems like every couple of years there's something new and exciting that is the new must-use framework. Recently, it was Angular. React is now looking like the new next big thing. Before Angular, there was Backbone, there's Ember, there's all these other different frameworks that are coming in and out of style. So my concern with a framework is that I don't want to get locked in. As styles change, as we learn new things about how to build software on the web, I don't want to be stuck with something that's going to require me to rewrite every couple of years. That's just not a good use of my time. So lock in. That is one of my concerns with front-end frameworks. Second is opinionated architecture. A lot of people describe the value of a framework is that it enforces an architecture upon you. I do not want that. I so do not want that. I'm pretty competent at building my own architecture. I don't need a framework to decide how my architecture should be put together. And if the framework is imposing an architecture on me, that means that I can't build something that's right for my app. It means I'm stuck with whatever they provide. Which brings us to the next thing that concerns me about a lot of frameworks, or that I worry about with frameworks, is accidental complexity. Some of these frameworks are done by people with, less than 10 years of experience. This may be their first major framework. That can be a recipe for, propeller spinning. Building something that is really, really cool. It's going to solve all your problems magically. But if you want to do anything outside their sweet spot, is really hard to work with. It can lead to difficulty troubleshooting. It can lead to magical behaviors that are hard to figure out. And it can also, frankly, lead to just poor design, which, when combined with opinionated architecture, is a really bad combination. So we're going to look at React and its complexity as well. And then, of course, if you're watching this show, you know I care about test-driven development. I want to be able to write unit tests around my code. I don't want to have to spin up something like Selenium just to test, or any other end-to-end framework. So testability is always a concern for me with frameworks, because a framework or library that is not designed to be tested can be extremely difficult to test. So how testable is the framework? How testable is React? And then one last thing that is specific to front-end frameworks. search engine incompatibility. A lot of these frameworks that are designed for single page apps do all their work on the front end, all in JavaScript, and you have to jump through some really amazing hoops, some really non-scalable, non-realistic hoops if you want it to be search indexable. So those are the things that I want to look at in this review of React. It is a little different than your typical front-end framework review. I'm not going to be looking that much at speed of initial creation or size of the library or performance. You can find that kind of stuff all over the web. What I want to look at is the stuff that I care about when I'm doing long-term professional real world development. And that is stuff about maintainability and testability and all these concerns you see here. So that is what we are going to look at today. Now, the tool, the way I'm going to do this is, or the test bed that I'm going to use, I'm actually going to re-implement an application that we built. If you watched my original screencast series, Let's Play TDD, several years ago, that was done in Java, you know that we made an application to do financial planning, to project our finances into the future and into retirement. And it looked like this. It was a little app that started out with some starting information and then projected it out over the years, took the balance and your expenses and taxes and so forth, and told you how much money you'd have when you died. Now, we never finished this app. It was just like this series, just like the live channel in Let's Code JavaScript. It was more about exploring the ideas than necessarily going as fast as possible. So this is a fairly small app, but it's small enough actually that I think it would be a good basis for testing React and the other front-end frameworks. We could, of course, build yet another to-do app, but everybody does that, and any framework that you find will be really good at doing to-do apps. The question is it good at doing anything else? Is it good at doing something a little more complicated? So I want to re-implement this financial projector, partly because it's more complex than a to-do app, but also because it has a couple of interesting architectural decisions in it. We're using the checks pattern language, specifically the concepts of whole value and exceptional value. The checks pattern language, by the way, was created by Ward Cunningham, and it's really fantastic. If you haven't seen it before, go take a look. It describes a way of approaching user interfaces and data modeling that I think is really solid. And that is the approach that we used in this financial projector app. In particular, we use the exceptional value concept, which says that if we put in an invalid value, you can see what's happened here is that we are now modeling that value with a different type of object. We're not throwing up a dialogue or anything like that. We're just having all of this pass through, and all the calculations are operating on this new type of object and rendering themselves differently than they would a normal number. But the underlying model uses the same logic. It's a little hard to describe, and I think we'll get into that more as the episode progresses. But it's an example of an architectural approach that most frameworks by default won't support. So the question is, will the front-end frameworks we explore in this series, will they support that kind of approach? Will they support a rich domain model like we have with this financial projector? And also, will they support the architecture of this application is a little bit avant-garde in that, as an experiment, as we were developing this in the Let's Play TDD series, I made a decision to never use getters and to use as few setters as possible. Instead, I wanted to have a rich domain model that talked about the problem we were facing here, which is stock market projections, and do that without using getters and setters. So that is an architectural choice I'd like to continue to take forward into React. Can we do that with the front-end frameworks? Can we do that style of coding in React? So that's the goal. We're going to be using the financial projector. We're going to try to re-implement it using React and see if some of the quirky design decisions that we used here that actually worked really well for us and gave us some nice power for responsiveness and also handling error conditions. Let's see if we can do those in React and use those to explore the concerns I have with these sorts of libraries and frameworks in general. Okay, let's get started. The very first thing we need to do here is just get a Hello World React app up and going. I'm going to go ahead and start working on that, and I'll be back in a moment. Okay, I've got a simple Hello World page set up here. It is very simple. It just says Hello World. And I've installed the React script tag. Now, the thing with React, the way React is designed to work, according to the documentation I've read, is it's really all about components. So what we want to do is, I guess what we need to do is try to make a Hello World component. And so I guess what I'm going to do is figure that part out. I'm going to get this set up with a component. So I'm going to do that. Be back in a moment. Okay, here's an example from their starter set. What you do is to create a component, you call react.createClass, and you pass in a render function that is responsible for rendering the component. And then to actually make it go, you call react.renderComponent, pass in where you would like that component to be instantiated. In this case, they're just using document.body. So let's go ahead and try that. Let's just try copying this in, see what happens. So if we load this up, well, nothing happened. Minified exception occurred. Well, that's not terribly useful. Let's take out the min. Invariant violation. Target container is not a DOM element. Well, that's surprising. It sure looks like a DOM element. All right, well, we're off to a bad start. I'm going to go ahead and work on this a little more. Okay, I figured it out. And it's something that's fairly obvious in retrospect. I had the script tag in the head up here, and that meant that the document body or the other elements I was trying to create didn't exist. So that's why I was complaining that the target container is not a DOM element. However, when I move it down to the bottom, after the elements I'm wanting have been defined, then it works just fine. So there we have an element that creates a component, or we have some code that creates a component called hello. That code has a render function that creates a paragraph tag with no attributes and hello. So if we refresh that, we can see it show up. Now we could also have this show something like the time. There we go. That isn't going to automatically update, though. To my understanding, in order to make it automatically update, we'd have to change some state or something like that. So, but there we go. And we can also pass in some properties. Let's pass in my name and have this say this dot props, I believe, dot name, and then we'll put the date. There we go. So there you have it. Fairly simple to get going. To create a new component, we define it with react.createClass, give it a render function. Now there's some other stuff that we have to do in terms of state and so forth when we're doing more complex things. And I think that's what we need to get into next. But once you have your component, you just define it and then you tell it to render somewhere, and you can really give it anything. Here we've got it showing up in the container, but we could also pass in presumably document body. And in my research, one of the benefits of React, or one of the cited features of React, was that it plays well with existing code in that you can have it render into part of a page without taking over the whole page. And I really do like that. So let's see. Yeah, there we go. It's working with document body. Okay, so what we need to do next is actually get our Java application implemented. So the recommendation is that you start out by just sort of mocking up your interface and then implement it either top down or bottom up. I think we'll implement it bottom up because that's what they recommend for larger applications, especially ones where you want to do testing. You will go in and implement each component with tests from the inside out. But all we need to do to get this thing started is just mock it up. Before we do that, though, I want to get into something that's a little bit controversial with React, and that's something called JSX. JSX is a little language. It's a superset of JavaScript that allows you to use something that's a bit more natural. One thing you might have noticed here is that React doesn't use templates. They're very proud of this, that React uses 100% JavaScript. But the syntax for doing that is, well, it's a bit clumsy. It's a bit clunky, and it doesn't read very cleanly. So they've created this language called JSX, which again is a superset of JavaScript that allows you to write tags directly into your code. So I should be able to do something like this: hello, well, let's see, a p tag, hello, and then this.props.name, and then the colon, and then new date, and then close that p tag. That is what you're supposed to be able to do with JSX. Now, in order to do that, I believe I need to pull in a JSX translator. That's something that you wouldn't do in production. You wouldn't actually render it on the client, transcode it on the client. Instead, you'd pre-process it in your build script. But to start with, let's just try doing this in dev mode, see if we can get this JSX working with the translator script. I'm going to go look into that. Be back in a moment. Okay, I've got the JSX plugin working, or the JSX language working. To make that work, you have to add this JSX transformer. Again, this is something you'd only do in development mode, not in production. And as the episode goes on, I do plan on doing this properly in production mode rather than development mode. But for now, that will work. And then for the script, you have to say that the type is text/JSX, and you have to add this comment at JSX. And if we do that and we load it, we can see there's our hello Jim. What you might notice here, though, is our dates disappeared. And this was surprising to me when I tried it. Turns out that we can't just instantiate a date here. We actually need to convert it to a string. So I'm going to do that by just adding it to an empty string. If we do that, then everything works properly. So I'm not exactly sure what's going on with JSX. That is the flaws of using little languages, preprocessor languages like JSX. They tend to have these weird, quirky edge cases, but it is a lot nicer to write this than that clunky react.dom.p thing that we had before. I'm not sure which one I like better. I think if I were doing this on my own projects, I don't know if I would use JSX. It tends to create problems in terms of debugging and so forth, linting. You don't get your normal suite of tools, but when you're using a little language like this, and they do tend to have these weird edge cases. But I'm going to go ahead and try it here, see how it works out, sort of withhold judgment, and see how that goes. All right, so now we have that. Let's go ahead and mock up the rest of our Java app. Remember what we're going to need here. We're going to need to break this into components. I think we've got the data entry piece. I don't remember what we called that in the Java app, but I'll look it up. Then we've got the actual table that renders everything. And then within that, we also have form fields with a label and an amount, and we also have rows with various columns. So I think that's how I will mock it up. I'm going to go ahead and do that off camera, and we'll be back in a moment. Okay, you can see I made a couple of basic components here, a configuration component that returns configuration goes here, and a stock market table component. I've rendered those separately into container 1 and container 2, and then when we load that, you can see that it loads up just the way it's supposed to. Now the next trick, in order to really make this work, I need to compose these. I think I can do that by just making another component that returns these two. And this is where using JSX comes in handy. I should be able to make this new component with a render function that returns, well, it should be able to say return, let's see. I need to put that in parentheses so we don't get a semicolon at the end. And then we should be able to just say configuration and stock market table. If I do that, and we'll put a line in between just for fun. If I do that, I think this will work. So we'll render that application to container 1. And it did not work. Adjacent XJS elements must be wrapped in an enclosing tag. Okay, so all of these looks like they need to be in a div. See if that works. Expected corresponding XJS closing tag for HR. Yeah, so this isn't really HTML. It's sort of this XML hybrid. So I'm guessing I need to put a slash there. I'm not sure what's going to happen though. Yeah, there we go. There's our user configuration, a line, and then the stock market. What this means now is that we have the ability to compose components into other components. That's really important for continuing to mock this up, because now what I want to do is actually create the three form fields that we need in our configuration. So the starting balance, cost basis, and yearly spending will go here, and then our actual table will be here. And that will be composed of rows, I think, and I think each row will also be its own component. So I'm going to go work on that a bit, see if I can continue mocking this up, and be back in a few. Okay, I've mocked up the configuration panel. You can see now that we have a starting balance, cost basis, and yearly spending. And the important thing here is this idea of properties. So the configuration panel is made up of 3 configuration fields, and I pass in the name of each field as starting balance, cost basis, and yearly spending. And that is accessed here when I'm rendering it. You can see it's just sort of really cheap. Just paragraph, the name of the property I pass in, and then a blank line where I'll put the input field. Input fields, I get the impression from my reading, are a little bit complicated, so I'm not going to put it in yet. I'm just going to mock it up with some blank lines for now. So inside of your render, you're going to use 2 basic things. You're going to use properties, which are passed into you by whoever creates you, and state, which is something you manage yourself. We haven't gotten to state yet. Presumably we'll get to that once we start doing some real implementation. But I wanted to see how the properties work. I haven't done anything with the stock market yet, so I'm going to work on that next. Okay, I'm back. I have finished the mock-up. This is pretty hideous, but everything is hard-coded. All the components are in place. We have a configuration panel with configuration fields and a stock market table with stock market rows. And you can see that here. We've got what's new since the last time I showed this to you is the stock market row just renders out some hard-coded data with a configured year. Stock market table renders out a header, and then the body, which is composed of several hard-coded years. So that is the mock-up of our application. Now what we need to do is start implementing this properly. And that also means that we need to get into some decent development practices. We can't just be doing this all in line. And we need to not do this JSX transformer in our actual production HTML. So I think what I'm going to do next is figure out, well, I guess the first thing I'll do is figure out how to get this code in its own file. And then from there, probably figure out how to incorporate the JSX transform into my automated build. So I'm going to get started on that and be back in a moment. Okay, I got the script extracted out pretty easily with one little glitch. When I first tried this, it didn't work, and it gave me the worst error ever, syntax error on line 5, saying that my title had a syntax error in it, which of course it doesn't. It does not have a syntax error in the title. What happened there was that you have to put this JSX marker at the very top of your file. And this was in the documentation. I remember reading it, but I forgot about it when I extracted this code out. So that once you do that, then everything works just fine. So that is working. Next, what I want to do is I want to get this transformer script out of our production HTML, because that's not something you want to run. It's going to really slow things down. They don't recommend that you include it in production code. This is just for ease of development. So now what we need to do is transform our JSX to JavaScript and load it up properly. So that is what I'm going to do next, and I will be back in a few. Okay, I've modified my automated build, which is written in Jake. It's right here in this Jake file, so that it will compile the JSX for me. And when it does, it will put it in a generated directory. So if I run Jake and then compile JSX, that will compile the JavaScript, the JSX to JavaScript, and put it right here. That was a little bit more painful than I hoped it would be, but honestly, I brought it on myself because I wrote this little JSX runner to do the transformation for me. It takes a list of files in an array and an output directory, and then passes through the JSX compiler options. I did that because I really like my builds to be fairly fast, and so I try to avoid them shelling out to an external script. So I could have run the JSX tool directly, but I chose to instead write this little JSX runner. And now that I have it, means that I don't have to spin up another instance of Node, which will save me a couple seconds, which is nice. So actually using this is just a matter of calling that runner's transform files function. And this is something you can use in your own projects as well. So now that this is working, I need to integrate this into the rest of my build so that I can just type Jake and have everything go. What that means is I need to get linting in place. Then we'll see what happens after that. Specifically, I think what I'd like to do next is get linting to work on the JSX files. I know that JSHint will work on the compiled output, and the compiler doesn't change any line numbers, so that should work, but I'm going to see if I can find a JSX specific linter as well. So I'm going to go ahead and do that and be back in a moment. All right, I did find a JSX hint program, but as far as I can tell, all this does is convert JSX files to JavaScript and then runs JSHint, which is exactly what we're doing. So that doesn't have a lot of value. So what I'm going to do is I'm just going to modify the lint code, the linter to run the compile JSX step, and then we will have that use our compile JavaScript, which actually I've already changed here. So now I should be able to say Jake lint and have that work. However, it doesn't like the code that it's emitted by the JSX compiler. Let's see. Yeah, this has got some problems. It's missing a semicolon here, for example. Or maybe the issue here is that I'm not doing a semicolon. Maybe that's all it is. What happens if I do that? So we need to run Jake compile JSX, and let's look at the output. Yeah, it looks like I am the one who left out the semicolons. Well, that's good news. I mean, it looks kind of funny having the semicolons there for sure, but let's try that. We'll lint that. Now it is complaining about a couple of things. We don't have use strict in here. There we go. And now it's just complaining about that new prefix, which that I can just turn off with a lint option. All right, I've got our automated build pretty much done. We lint our node code, we compile the JSX to JavaScript, we lint the JavaScript code. If you're interested in using this code yourself, you of course can use the source code that comes along with this lab. Just check out the link below the video. So that is all up and running. It's pretty darn good. I'm happy with the automation, and automating React so far has not been that tough. What I want to do next is we've got our JSX all in one giant file. I want to split this out into multiple files. I like the idea of having each component be in its own file, except for maybe the stock market row and table. Those seem like they would go together. But I want to have the configuration panel and field in a file. I want the stock market table and row in a file. And I think I want the application in its own file. That's going to require us getting Browserify up and running. So I'm going to go ahead and do that. You can see this Lessons Learned episode here for how Browserify works. I think I'll be able to just steal that code and run with it. And once that's working, I think we will be done with the automation portion of this, and we can move on to the next thing, which is going to be actually implementing the one of these components and getting tests around it, which is something I'm really curious to see how that's going to work. Anyway, I'm going to get Browserify working, and I will be back in a few. All right, I've got Browserify automated. As before, I've extracted this out into a Browserify runner. And the way it works is you just pass in the list of files, and it will convert it into a bundle. Then when we run our script, it will go ahead and do everything, bundle up that deploy directory right here. Now, what I haven't done yet is I haven't actually extracted out these files yet. So, and I'm not exactly sure how to do that, but I think what I'm going to do is just try it. Let's go ahead and make a main file and a example.jsx, and the main is going to just have the render component, and the example, let's see, and that will take the application. So I guess what I need is I need to import the application. So I'll import example.jsx and see if we can get an application exported from that. And an oh wait, that's example. All right, there we go. So now we've got main importing application from example.jsx. And actually, I think I have to import it from example. Just do it this way because the JSX is going to get converted to .js, and the Browserify won't recognize that it's called .jsx. So I'll just import it from example and leave off the extension. That will work just fine with Browserify. And then in here, what I need to do is say exports.application equals application. And that should make the application available to main.jsx. Well, fingers crossed. Let's see if that works. We'll go ahead and build it. We've got a lint failure just because of the CommonJS stuff. So that's going to lint now, saying it can't find module example. Okay, I figured it out. It was a silly little error. I forgot the /. If you don't have that, then Browserify looks in the node modules directory or something like that. I also had an error in my Browserify runner, which I fixed. I don't think that's worth going into right now, though. So, but if you're curious, you can look at the source code. At any rate, now we've got this in multiple files. It is working. Now I think what I want to do is split it up into multiple modules, one for each type of component. So I think I'll make one for configuration panel, and I'll make one for stock market table. So let's go ahead and start out by making a configuration panel .jsx, and let's try to spell that right. And for configuration panel, we need the configuration field, but that is it. And our exports, yeah, let's export, let's do it this way. Let's export configuration panel. It's configuration panel. And we don't need the application. So there is that. Now that's should not work if I run that. So let's go ahead and rebuild, and we run it. Oh, it does work because we're not using it yet. So let me come over to here in our example, take it out, and now if we rebuild, configuration panel is not defined. Our lint fails, which actually the documentation said would happen, but I'm really happy to see that happening here. We have used configuration panel, where we used it, right here, but it is not defined. So that was nice. So here I'll say configuration panel equals require configuration panel now it's saying configuration panel is not a function. Oh, I figured it out. Another dumb mistake. If you're going to export something from a module in a CommonJS, then you have to actually get it out. So if I say configuration panel here, then this should work. And in fact, it does. But actually what I'd like to do, I like the idea of just requiring the configuration panel. So what I'm going to do is I'm going to say module.exports here and do it that way. So anyway, this should work now. And there we go. And there we go. Okay, I have got all the modules split out. I even put them in their own UI directory, which will be nice as the application grows. And I'm pretty happy with this. I think that pretty much does it for our build automation and sort of general structure piece. We've got everything linting and compiling and collating and bundling and everything like that. Our actual HTML is pretty clean. We just load the React module, which I've decided to keep separate, and then we load the bundle. And that automatically has all of our JS and JSX in it. Now that we have this all split out into nice components, the next thing to do is to figure out how to test them. And in the process, I think we will also start working on turning them into real dynamic components. So that is what's next. Let's go ahead and get started on that. Okay, I've got the tests up and running, and part of my automated build, I'm using Karma here, as you've seen in other episodes. If this is your first time joining us, then check out this episode right here for a primer on how to use Karma and how to make it work with the CommonJS bridge for Karma, which allows us to use the browserified modules inside of Karma. So what you can see here is that I've got the tests working. I'm running React on IE8, IE9, Firefox, Safari, Chrome, and the iOS simulator. Actually, it's Firefox, Safari, Chrome. But regardless, they are all working. It was a bit trickier than I thought, particularly with IE8, as usual. And that's because I had to get the AS5 shims installed for IE8. I had to put them into the example HTML and also into the Karma config file. Otherwise, the test wouldn't run on IE8. Now, the tests I've got so far are really, really simple and dumb. It is just a do-nothing script. That was the first step to make sure this was all working. Now what I'd like to do is try to figure out how to actually test a React component. And there is a React test library. If we look at our add-ons, there's this test utility. It is called test utils, and it simulates events, which is helpful, but we're not really needing to do that. And it will render a component into a DOM element. So I think the next thing for me to do is to actually get this add-on as part of our test library, see if we can start running it. What I'd like to do before I finish up this part of the review is just get a simple test up and running so that we can see how it works. Then we'll have a complete skeleton of an application up and running. And then next time, in the next part, what we can do is look at the architecture and design considerations. So I'm going to go try to figure out how to get that add-on installed, and I will be back in a few. All right, I've got the test utils installed. That was really straightforward. I just needed to download the React with add-ons library and modify my Karma config to use that. And now we have a test utils. If we run our test, we can see that that is defined. Now, I haven't tried to do anything with this yet. Let's see what happens. Let's talk about our stock market table. And it should, what is it going to do? Well, we're going to have it just output hard-coded data for now. Again, what we're doing here is we're just getting all of our tooling up and running, all of our basics up and running. And then in the next part, we'll actually work on implementing this and getting the architecture and really looking at how React supports the design work we want to do. In order to do this, now the test utility is supposed to render into the document and give us a component back. How exactly does that work? I'm not entirely sure. Let's try doing that. Let's just say test utils dot render into document, and because this is a JSX file, or at least it will be as soon as I put on that sort of magic sigil. There, since this is a JSX file, we should even be able to say stock market table, just like that. By the way, you may have noticed that I'm getting syntax highlighting. I just told WebStorm that this was a JavaScript file, and it seems to be handling it pretty well. It has trouble with refactorings, but other than that, it's actually working surprisingly well. Anyway, so there's that should create our instance, I guess. Let's just dump that out and see what happens. All right, we're getting an error that stock market table is not defined. I suppose I need to require it. Well, there it has been dumped out. We got a whole bunch of stuff from it, and what do we do with it? I don't know. I really don't. I'm gonna go do a little more research into this, and I'll be back in a few. Okay, I think I'm starting to figure this out. There are a couple of things that we can do. First, plain old React has something called render component to static markup. And when we call that, it will turn our component into just normal HTML without all the crap that React normally puts in there to sort of manage its DOM stuff. So that's pretty clean. That is basically exactly what our component creates. If you look at our actual stock market table component, it does a T-head, a T-body with a bunch of rows in it, and it looks a lot like that. So that's cool. And then if we want more structured access, the test utils has these various find, render, DOM component, etc., things. Scry render DOM components with class, with tag, with type. So that is something that we can use to sort of more surgically get into what we're rendering. Render component static markup is good for sort of simple dumb testing, and this is for more sophisticated testing where we want to get in at a specific module. So I think what we're going to do now, I need to wrap up this episode because it's getting a bit long. But what I'd like to do is just one simple little test. Next time we'll get into a more complex example, and we'll actually flesh out our financial projection application into a real app. But this time, just to prove that we know what we're doing on testing, which hopefully we do, I want to test that we are, in our stock market rows, that we're outputting the year that we said we would. So what I'm going to do is I'm actually going to extract this stock market row out into its own module and then write some tests around it. So first, let's go ahead and create a new. So that is pretty nice. I really am liking React, to be honest. I love the way the components work. They're very straightforward. Now, we haven't tried to do any real interaction yet. We're just rendering stuff. So that is understandably not quite the same thing, but even so, I am liking it. Okay, so let's rename this test to be about testing the stock market table row. And we're passing a year with 1989. So let's say that it incorporates year into row. So we'll output that. I think if we just render it to static markup, we will see that it comes out. Now here, this needs to be a stock market table row, year equals 1989. The render component to static markup actually doesn't use this, it uses this. So the test utils, find, render, DOM component, blah, 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 that's going to use what you'd use with render into document. But if we're going to just render it out to static markup, we can just hard code our values right in. So if I do that and I run it, what do I get? Well, I get dumped out the value. So that's good. So I guess what we're going to say is that renders static HTML with year. This is going to be the rendered value. And we can expect rendered to equal that string. And that works. A little bit slow. It's actually a lot slow, but maybe that's just a one-time spin up. We'll see how it goes as we continue on. And if I change this, if I break this so that we are no longer passing in the year, then our test should fail. Okay, that's cool. So we definitely have static markup working. So we can test our component by just comparing it directly to a raw string. Whether or not you want to do that in all cases is debatable, but that at least is an option. So I'm going to go check this in, and then we'll look at the next option, which is to use our testutil functions to be a little more targeted about it. Back in a moment. Now what I'd like to do is be more precise and write another test that goes in and tests the precise rendering of our component. So that's where we will get our row here, and we will, well, I guess what we need to do is find the first data, the first table data element. So the way we do that is we scry rendered components. Find means one. There must be exactly one result. And scry means find all the results, and then it returns it in an array. So we should be able to say testutils.scry rendered DOM components with tag row, and we were looking for our first table data element. So our first TD is that dereferenced to 0. Now let's go ahead and dump that. We'll dump the first TD, get the DOM node that is associated with it, and dump out the inner HTML. Just like that. And that should be just 1989. We couldn't find the element. All right, after investigating this further, it looks like what's going on here is that when we render this fragment into the DOM, the browser changes its structure, and that confuses React. So if I actually put a table and a tbody around this, then my test works just fine. So you can see that there. Now what I'm doing in the test is I'm just rendering into the document and then dumping out the node. So you can see it's working fine. Here it did dump out with the tbody and so forth. That is the inner HTML. But if I were to take the table off and just go with the tr, which is all we want, this component is just a row, then in that case this will fail. If I run this again, I get that exception, which basically says React can't find the element. And this is not too surprising to me because React's doing something kind of dangerous, or at least daring. They're re-implementing the DOM. And re-implementing the DOM, I understand why they're doing it. It gives them a lot of control over their rendering engine, gives them a lot of performance, or so they say, and I believe them. But whenever you re-implement something as fundamental and as large as the DOM, you're going to create, you cannot help but create these leaky abstractions, as Joel Spolsky says, these just little edges where things don't work the way they're supposed to, the way you would expect them to. So the bottom line on this, for testing anyway, is that we cannot use these find blah, blah, blah techniques in anything that is not legitimate, a completely rendered DOM object. A TR element somehow, when it's being rendered into the document, is getting mutated and bizarroed and messed up so that all we can do is static rendering. All we can do is this static testing. Okay, wait, I just had an idea. Now, if we try to test this stock market table row, because it doesn't have a table around it, we'll get a failure. And we can see that right here, the find component root failure. But it's occurred to me that the only problem is that we don't have the table tag, right? So I can add that to my test. It's a little clunky, but it will still work. I'll add the table body and the table, and now I will bet you this passes. Oh, and it sure does. And look, there is our 1989, which is exactly what we need. So what we can do is we can say expect the first TD's inner HTML to equal 1989. That gives us a targeted test, which is a lot cleaner than this because it talks about what we care about. It tests exactly what really matters, which is this bit of logic here. I don't generally test stuff that's just hand-coded or hard-coded. I like to test the logic of my units. And in this case, the only logic we have is that we're getting the year in there. And that is what we are doing. We are testing exactly the property logic of our component. And that works. It's a little bit of a hack, but that is clean enough. I am pretty good with this. So there we have it. Two different ways of testing. One which looks at the static HTML, and one that looks very targeted at specific elements that we are rendering. And you can see how we could expand this out to look at other elements as well. And next time, when we get into more details of fleshing out our mocked up application here and turning this into a real application, we will get into that. I do have to say, having worked with this code for a little while, I don't think React's test story is fully baked yet. It's okay. And the component approach is really nice. And the fact that I can do this without mocking, because if you've been watching me for a while, you know I don't really like to use mock objects. The fact that I can actually test a component for real is really nice. But it's the documentation, the amount of information available, and the library support, just not quite there yet. But it's good enough that I think we can continue to work with it. And with that, we come to the end of the first half of our investigation into React. What we've done in this episode is we've created a mock-up of our financial projection app in React. We looked at how React components worked. We did a lot of automation work. A lot of it was off camera, but there's a lot of automation work into making this really clean, really fast to run, really convenient. And you can find all of this work already done for you at the source code, which is available at the link below this video. We also worked on modularity so that we could separate each module into its own JSX component. And we looked at testing and how can we test our components. Now, with all of this in place, what we can do next time is really start to implement our financial projector app for real. Build it out, see how React influences and affects our ability to create our own architecture, our own approach to design. That should be really interesting, and that will get us into a lot more depth in terms of how well React is testable, how easy it is to work with in terms of events and having everything communicate with each other. So I am looking forward to that. That's going to come up next in part 2 of this exploration into React, a front-end library for JavaScript. Thanks for joining me, everyone, and I will catch you next time.